Hello and welcome to another Algebra 1 video tutorial. In Lesson 11.6 we'll be looking at special binomial products. Our goal will be to apply two patterns of binomial multiplication, the square of a binomial and the difference of squares, to do arithmetic multiplication mentally, and to illustrate how a knowledge of algebra can contribute to increased arithmetic proficiency. Alright, so expand and simplify. The quantity n plus 5 squared. Okay, so what would that look like? Well, the common mistake is to just simply say n squared plus 25. That's what most people think the quantity n plus 5 squared would be. If it was only that simple, it would be nice. What are we missing here? Well, let's just prove that that doesn't work, or let's just find a counter example. Let's just say n is 1, okay? So if n is 1, the common mistake would say, all right, 1 squared plus 5 squared, that would simply just be 1 plus 25, which is 26. But we know 1 plus 5 is 6, and 6 squared is 36. Well, that just shows right there when n is 1, 36 doesn't equal 26. So that doesn't work, okay? So what would work? Well, we know how to expand and multiply. So we could say this is the quantity n plus 5 times itself, quantity n plus 5. And then with the extended distributive property, we'd take n times n, so we'd get n squared, n times 5, 5n, plus, now we move to the 5s, 5 times n, plus 5 times 5. So there is an n squared plus 25 in there, but there's also an extra 5n and 5n, so this is simply n squared plus 10n plus 25. Okay, let's try if we just have variables. The quantity x plus y squared. So we, once again, would take x plus y times the quantity x plus y. And then what we'd get is x times x, x squared, x times y, xy, plus y times x, which is still xy, plus y squared. So the common mistake would have been to say x squared plus y squared, which is there, x squared plus y squared, but there's also two of these. So x squared plus 2xy plus y squared. So can you see a pattern just in those two? What is the pattern? Well, what if it's subtraction? This is going to be the quantity n minus 6 times the quantity n minus 6. So n times n, n squared. N times a minus 6, so minus 6n. A minus 6 times n, so another minus 6n. And a minus 6 times a minus 6 would be plus 36. So this is going to be n squared minus 12n, because we have two of the same. Hopefully you're starting to see that. We're ended up with two of the same. Two of the same, that's a common mistake piece to miss. So this 5n and 5n become 10n, xy and xy become 2xy, a minus 6n become a minus 12n. Let's try one more here. So we're going to go the quantity m minus n times the quantity m minus n. So we're going to get m times m, m squared, minus m times n, minus n times m. Minus n times a minus n would become a plus n squared. So what happens here? Well, we're going to get m squared minus two of these, mn plus n squared. So we call this perfect squares of binomials. So if you have some quantity squared, whether it's a sum or a difference, the pattern is going to be a squared plus 2ab plus b squared, or it might be the only difference between these top two and the bottom two was the middle term was negative. Okay, so a minus b was going to be a squared minus 2ab plus b squared. All right, so that perfect square of binomials. Here's a picture of what it looks like with using algebra tiles. So we'd have a plus b would be a squared plus 2ab. So notice that this is going to end up with two of the middle terms plus b squared. Now if we change this to the minus, so this just becomes plus a negative, so that just becomes a squared plus b squared, but we also have two of the minus ab's, which is this guy right there. Okay, so what should happen here is if you see the square of a binomial, you should be able to apply the pattern fairly quickly. Okay, rather than multiply each one out using the extended distributive property, we should realize that we're going to get x squared plus 1 squared, but you're also going to get two of the middle terms. X times 1, but you're going to get two of those, so it'll be plus 2x. Here we're going to get x squared plus 4, right, 2 squared, but we're also going to get a 2x and another 2x, so that would be a plus of 4x. Here we're going to get x squared plus 9, but don't forget a 3 times x, but we're going to get 2 of those 3x's, so plus 6x. Here we're going to get x squared plus 16, but we're going to get a 4x and another 4x, so we get an 8x. Here we're going to get x squared plus 15 squared, which is 225, and then a 15x doubled, so plus 30x. Here we're going to get x squared plus n squared, but we're going to get an xn or an nx, 2 of those, so plus 2nx. All right. What if it was the quantity a minus b squared? The only difference is this middle term is negative, so this is going to be x squared minus 2x plus 1 squared, x squared minus 4x plus 2 squared. This will be x squared minus 6x. So what I'm doing, I'm just doubling the 2ab here, a times b. So the x times 1, double it, x times 2, double it, x times 3, double it, plus 3 squared, which is 9. All right, x squared minus 4x, double it, will be 8x, plus 16. X squared, double the 15x, so minus 30x plus 225. And then x squared minus 2nx plus n squared. Okay, so see how fast that is rather than multiplying it all out. You should be able to do that mentally because it's of the patterns. All right, you all know some people that multiply 2 numbers fairly quickly. They might use something like this in their mental process without showing it. So we're going to calculate this 32 squared mentally. We're going to show it basically on paper. So what could this be that's a little easier calculation? Well, this could easily be the quantity 30 plus 2 squared. All right, so if we think about that as 30 plus 2 times the quantity 30 plus 2, we're going to do that extended distributed properly, but we're also just squaring a binomial, so it's going to be 30 squared plus 2 of the 2 times 30, so 2 times the 2 times 30s, plus 2 squared. Okay, so 900 plus 30 times 2 is 60, 60 times 2 is 120, plus 4. So we add those together, we get 1024. So that might be the mental process that someone you know that multiplies 2 numbers quickly will use. So this is what I want you to show when it says calculate mentally. Just so I know you didn't use a calculator, I want to see this process that you change it to the square of a binomial and then use the pattern. All right, let's say the area of a square with a side 4d minus 3 is the quantity 4d minus 3 squared. Expand this binomial. Well, we just have the square of a binomial, okay? So it's going to be 4d squared, well, 4d times 4d, so that's 16d squared. Okay, now it's a minus, so we're going to get 2 of these terms doubled. So 4d times 3 is 12d, but it's doubled, so it'll be a 24d plus 3 squared, which is 9. So that's what this would look like. Now we could also draw a picture with a rectangle if we wanted to. So we'd have a 4d minus 3 and a 4d minus 3. So it looks something like this. This right here would be 16d squared because it's 4d times 4d. This would be a negative 3 times 4d, so negative 12d. This one's a negative 12d, so notice we had 2 of those to make a negative 24d. And then a negative 3 times a negative 3 would be as a plus 9. So that's what it would look like as a picture. All right, let's say we had the product of a sum of 2 numbers and a difference of 2 numbers, such as the quantity n plus 5 times the quantity n minus 5. So this is another special pattern. So we'd go n times n, if we're doing the extended distributed properly, n squared, n times the minus 5, so minus 5n, then we move to the 5, so plus 5 times n, and plus a 5 times a negative 5, which would be minus 25. So what happens here is these 2 terms cancel out. A minus 5n plus 5n, those 2 are opposite, so they go to 0. So it just becomes n squared minus 25. See if you can pick up the pattern on that one immediately. So this one would be j squared minus 8j plus 8j minus 8 squared, which would be 64. So this is going to simplify to j squared minus 64. So what we call this is the difference of two squares. So if we have the product of a sum and a difference, it's going to be a difference of two squared. So the quantity x plus y times the quantity x minus y is going to be x squared minus y squared. And this one's probably simpler than the square of a binomial. All right, so let's do this. So let's, rather than multiply each one out, let's just use the pattern. This is going to be x squared minus 1 squared, x squared minus 2 squared, x squared minus 3 squared, x squared minus 4 squared, x squared minus 15 squared, and x squared minus n squared. That's pretty quick multiplication because these are a difference of squares. All right, and let's compute 23 times 27 in your head. I'm going to show you how I want you to show this on paper when it asks you a question such as this. Well, how are 23 and 27 related? Well, they're the same distance from 25. This one's 2 under 25, and this one's 2 over 25. So how could we write that out? Well, this is, first one's 23 is going to be 25 minus 2, and 27 is going to be 25 plus 2. See what I did? I went halfway in between there. They're the same distance from 25. So we would say 25 squared minus 2 squared. 25 squared is 625. 2 squared is 4, so this would be 621. That's a pretty quick calculation without using a calculator. All right, expand the quantity 3x cubed minus 2 times the quantity 3x cubed plus 2. This is a difference of two squares as well. So we're going to get 3x cubed times 3x cubed, so the quantity 3x cubed squared, so that's going to be 9x to the 6th minus 2 squared, which is 4. So these are pretty quick using patterns. All right, so that wraps this up. Get handy at doing these. Section 11.6, page 688, 2 to 36 evens. Thanks for tuning in, and we'll see you next time.